Good morning, students. In the last class, we discussed about the resonance effect. Okay. So, what is that resonance effect? The delocalization of the pi electrons. Understand? The delocalization of the pi electrons results in polarity of the molecule. For example, as I told you, and take only one example here. So, this is the benzene. Here, pi bonds are there. If they delocalize, means this is the position of the pi bond. If they delocalize from here to this position, then they form minus charge at this position and plus charge at this position. Means this resonance effect induce polarity to the molecule. By what? By the delocalization of pi electron. Okay, this is resonance effect. So in this resonance effect, two types is there. One is plus R, means plus positive resonance effect, or it can be also written as plus M, because resonance effect is also called as mesomeric effect. Understand? Another one is minus R or minus M, means negative resonance effect or negative mesomeric effect. So students, I'll take the example here. Okay, it is like this. Assume here and H2 is there. This is electron rich. Okay, load pair electrons are there. Understand? You may take this instead of NH2, you may take Cl minus also, OH minus also, and Nr2 also, etc. One which has a load pair of electrons. Understand? So this is the example for positive resonance effect. So what happens in the resonance? These lone pair electrons of nitrogen involved in resonance. That means, so this one shifts here. So then these electron shifts here. Understand? So listen, I'll write the structure. This is benzene ring. This is the common bond. They didn't affected by anything. So here single bond NH2 is there as I wrote. So listen here. Here two electrons are there. They are shifted to this position. Means of course two electron forms one bond. Understand? And this will become plus. And here the electrons are shifted here, and this will become minus. Understand? And the next. So in the benzene ring, follows same thing. This shifts here and this shifts here. So and the bond forming takes place, sorry, as it is bond is written here, and here the bond formation takes place at this position. Here it will get minus charge, and it is double bond NH2. Understood? And the next, this shifts here and this shifts to this position. Not like this, like this. Understand? So then you will get the resonance structure. Here the bond form will here double bond NH2. Correct? So this is unstable. So to become stable, again these electron shifts here. So then this finally becomes, sorry, the bond positions are formed like this. NH2 with the lone pair. So there is no much difference between the first and the last structure. Only the difference is what? This bond position. Understand? These are what? Resonance structures or resonance canonical forms. Understand? And finally we are going to write a resonance hybrid like this. Yeah, NH2. Delocalization, we may be right like this, we may be right in a sphere. So circle inside the benzene ring that represent what? Delocalization. Because so what is the delocalization means? They are not fixed for a particular position. Understand? So students remember here. So what is the thing you are going to observe here? This is one thing. NH2 is there, lone pair electrons are there. Those are involved in resonance. Initially, I will write the example. Later, I will explain what is how it takes place. What is plus R and minus R called as. Okay. So here I will take the example of NO2. Understand? So students, structure of NO2 is like this. N double bond O, single bond O. This is the structure of NO2. Understand? Okay. So listen here. So here what happens? So instead of NO2 to show you, this one is good. Next, listen here, students. Instead of shifting of pi electrons towards the system, here it takes place like this. Understand? Your oxygen will get the loaded electron, and these electron shifts here along with the bond. Pi electrons bond shifts here. Here what happens? This one per electron shifts here, and this one shifts here. But here, from the system, it is going to the next towards the atom. It is moving. Okay. So listen. How the structure will take place? A resonance will take place. Here two bonds are not affected. Understand? And here double bond will form because these are shifting here. And N single bond O. Here also single bond O. Here the electrons. Understand? So these pi bond shifts here means two electron. These pi bond shift here means another one bond. So these two are unaffected. And here the electrons are shifting here means this passes positive charge. Understood? Here towards this means of course extra one electron is present here, so that's why I wrote minus. Here it is moving towards here, so here one electron of carbon is less. That's why I am writing plus charge. And this positive effect is involved in the resonance. So then what happens? Same I will write the structures here. This pi bonded electron shifts here. Understand? So then here bond takes place, here also bond takes place, here positive charge, here double bond N, single bond O, double bond. So single bond O. Okay? Next. Listen, you cannot write this positive charge shifts here. Because here already electron is less. Movement of electron takes place, not proton. This plus represents what? Proton. Here why I consider this one means because these electrons are going to involved in the resonance. Understand? ಇಲ್ಲಿ ನಾನು ಮೈನಸ್ ಚಾರ್ಜ್ ಅನ್ನ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಬರಿತಾ ಇದ್ದೀನಿ. ಇಲ್ಲೇನ್ ಬರಿತಾ ಇದೀನಿ? pi bond ಶಿಫ್ಟ್ ಆಗ್ತಿರೋ ತರ ಬರಿತಾ ಇದೀನಿ. ಇದು ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಾ ಇಲ್ಲ. Are you getting? ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಮೂವ್ ಆದಾಗ ಇದು ಮೈನಸ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. In each case I represent movement of the electrons here, but here I cannot represent movement of the electron because here electron is already less. So I have to show only the change in the displacement of what? Pi bond position from one position to another position. If this pi electron shifts here, only this, then this will get the positive charge. Okay, and the next, and this will shift here. Then here bond is formed here, and here it will get the plus charge, and double bond N, single bond O with the local electron. Okay, next. At the same time, listen, This shifts here. Understand? And these lone pair electron shifts here. And finally, we form original structure with the alternate double bond position. Here, single bond O, double bond A. Are you getting? So finally, you will get the resonance hybrid. We are going to, as I told you, may write like this, write like this also. You can't write like this. This is wrong. Benzene ring you have to show means you have to write completely like this. Understand? So the benzene ring but because of full stop the chikkadagish round ಮಾಡಿದ್ರೆ that is wrong. You have to represent a big circle inside that benzene ring. Understand? Okay. So listen, this one is the example for what? Minus R effect. This one is the example for plus R effect. And now, what is the definition of minus R and plus R? Listen here, what happening? Here the lone pair electrons are there. Means the electron is moving towards what? This one, system. Consider this benzene ring as a system. The electrons are if the electron rich groups are electron releasing groups. These are electron releasing. So attached to the system, then the electron movement takes place towards the system, then it is positive resonance effect. If the electron movement takes place towards the system, this is taking towards the system. And here, the electrons are taking place away from the system, or from system to atom. Atom to system plus R effect. System to atom minus R, negative resonance effect. And remember one thing here, negative charge is there. If negative charge is there means by what reason they are exhibiting minus charge? Due to plus species. Understand? Due to positive species. So that's why it is plus R effect. One which causes a negative resonance, that is plus R effect. One which causes positive resonance, that is negative resonance effect. Just quietly opposite. In the SRS class also I did same thing. Okay? And remember here, so here the example I wrote Cl minus, OH minus, Nr2 here. For this type of compound, it is COOH. Why? Because the COOH structure is C double bond O OH. CHO, C double bond O H. CO, C double bond O. Next, C double bond O OR. Understood? Means you have to consider if any bond which consists of or here any atom is there that consists of already a double bond. Here, no one element consists, no one atom molecule consists of a double bond. OH means single bond only, Cl means single bond, NH2 means single bond. This Nr2 also single bond. If single bonded atoms are bonded to the system, then they show positive resonance effect. Because there is only one possibility of the movement of the electron is towards system. But here 5 electron is there, 5 bond also involved in resonance. ಯಾಕೆ ಅಂತ ಹೇಳ್ತೀನಿ ನೋಡಿ, ಇಲ್ಲಿ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಇದೆ ಅಂದ್ರೆ resonance effect ಯಾವ ರೀತಿ ಬರೋದು, delocalization of 5 electrons. Correct ಅಲ್ವಾ? So 5 bond is present in benzene ring. If I take NH2, that is written as NH. If we take OH, this is OH. If we take Cl, that is Cl. So the species here are what? Single bonded compounds. So single bonded compounds. So what is the resonance? Means the delocalization of pi electrons. Here there is no pi electron means. Understand? The resonance cannot take place within this molecule. So resonance only takes place in the system. But here, in case what happens? Here is a double bond is there. So if you take the example here, C double bond O OH. Okay. So alternate pi bond here is also there. Means this is also involved in resonance. Understood? So if this type of compounds are there, at least the bonded atom consists of a pi bond, then they probably show minus bond effect. Because the pi bond in that type of atom also involved in resonance. Just now I wrote here. So the pi bond electron, this pi bond, double bond, also involved in what? Resonance. But here, this NH2 group doesn't involve in resonance. This become unstable. Understand? So this one is what? Plus R and minus R effect. So what is the plus R effect? So plus R effect means if the electrons is moving towards the system, that is positive resonance effect or positive mesomeric effect. If the electrons are moving away from the system, then it is negative resonance effect or negative mesomeric effect. Okay, so this is all about the resonance effect. So students, if in the system, assume in a reaction, both resonance effect is there, electromagnetic effect is there, and inductive effect is there. Which one is most predominant means that is resonance effect. Means resonance effect is highly stable than electromagnetic inductive. Okay. So the next one is hyperconjugation. Next one is hyperconjugation. So students, this hyperconjugation is nothing but delocalization of sigma electrons. Delocalization of sigma electrons. Understand? Initially what I said, that is what? Delocalization of pi electrons. This one is delocalization of sigma electrons. Understood? Okay, listen. So I'll take example of ethane. So I'll take the structure like this. Okay. So this structure, one dissociates as H plus. So if we break that, this dissociates as H plus, this one plus C minus. So after dissociation, I'm telling this is C bond H, 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 single bond C, H and H. Here minus and here. Or if you just break the bond, don't write the bond here. As if you are breaking that bond, then here it is H plus and this must be a minus. Understand? Okay, so listen here. sigma electron means here it will take minus, here it will take plus charge. To the same carbon atom, of course, these two hydrogen is also there. Correct? Or, so listen, instead of this, the sigma electron transfer takes place. Means assume, so this electron completely transfers to this bond position. This electron completely transfer to this position. So then here C triple bond H, here it will become double bond. Correct? CH3, CH. And here it will get the minus charge. But I won't represent minus charge here because listen here 1, 2, 3, 4 bonds are there, then it is satisfied because carbon is tetravalent. Here 1, 2, 3, 4, 5 bonds are there, of course this will get minus charge. And this is unstable. I am telling about only the effects which are going to exhibit in the reaction mechanism due to the formation of intermediates, carbocation, carbon ion and also carbon free radical. So those are intermediates. Intermediates means they are just formed in the mechanism but they are not the final products and they are unstable also. So listen, and here it becomes H plus. These sigma electrons of H plus means this sigma bond shifts here and it represents like C, H, 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 double bond C, H, here bond will form and here H plus will form. Next, so instead of this bond may exhibit, involved in this resonance means C, H, 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 double bond C, here H plus, here H, H. Means here what happened? Of course, the bond position of each hydrogen atom keep on changes. Okay, by what reason? By the delocalization of sigma bond. A sigma bond shifts from one position to another position. So this effect is called as hyperconjugation effect. So when this effect is highly more effective, means when this is highly predominant. Listen, so in the initial class I told you primary carbon, secondary carbon and tertiary carbon, right? Listen here, if carbon atom is there, carbon, carbon, carbon. So here it is CH3, CH2, CH2, CH2. Assume here OH is there or any functional group is there. So students, here if we are not considering any functional group, and consider carbon number 1, 2, 3, 4 here. Okay, so with respect to 1, carbon 2 is the alpha carbon atom. With respect to carbon 1, which is next to that carbon is the alpha. Next one is beta. Next one is gamma. If another one is there, that is delta. Alpha, beta, gamma, delta. Those are the numbers, names in Greek or italic. Okay, alpha, beta, gamma, delta. With respect to what? With respect to carbon number 1. But with respect to carbon number 2, which is exactly next to that carbon, this is also alpha. This is also alpha. Are you getting? So listen, I will take here CH3, CH2, 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 CH3. Same compound it is. With respect to this carbon, only one carbon is next to this carbon. So alpha carbon atom is only one. But with respect to this carbon, 2 carbon atoms are exactly next to it. So this is also alpha carbon. This is also alpha carbon. If we are considering this one as a main carbon, this one is alpha, this one is alpha. And here it is beta, here it is gamma. Understood? So if you consider the same compound, CH3, CH2, 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 CH3, I am considering this carbon atom as a main carbon. Then how many alpha groups are there? Which is next to this? This is alpha, this is alpha. And of course, this one is beta, this one is beta. Understand? These are the position of the carbon atom in the parent chain or any other R group. It may be a benzene ring or any other. So, but listen students, this hyperconjugation is mainly observed in aliphatic compounds, means straight chain compounds. Resonance is in aromatic. This one is in single bonded compounds and especially aliphatic. Aliphatic means straight chain. Okay. So listen, instead of this, if we consider any functional group, I'll take here, that is CH3, CH2, 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 OH. So the carbon atom to which functional group is attached, that is considered as alpha carbon atom. The carbon atom to which functional group is attached. Here the functional group I am taking is OH. So this one is alpha, this one is beta, this one is gamma, and this is delta. So if you take this, that is CH3, CH, OH, CH2, CH3. Okay, so this is the functional group, and of course this is the alpha carbon. If this is the alpha carbon, the next carbon is beta. Here also the next carbon is beta, and this one is gamma. Understood how to find out alpha, beta, gamma position? So this is the way. If the functional groups are there, then the carbon to which the functional group is attached, that is the alpha carbon. And the next to alpha carbon, that is beta. Next to beta, that is gamma. Next to gamma, delta. For gamma, that's enough for you. Delta position they won't ask. Understand? Next. Why I am telling this? So listen, this hyperconjugation is very, very effective if alpha hydrogen atoms are more in number. Understand? So if this is the carbon atom and this is the alpha carbon atom. So if the alpha carbon atom consists of more hydrogen, means alpha hydrogen, means listen, if CH2, CH3 double bond, CH2 OH. Understand? Here this is the alpha carbon. So to this alpha carbon, two hydrogens are attached. So that's why this is alpha hydrogen. This is beta carbon. So that's why these are called as beta hydrogen. That is the name. Why they got name alpha beta means because they attach to the carbon which is present in the alpha position, then they are said to be alpha hydrogen. If they attach to the carbon which is at the beta position, then they are said to be beta hydrogen. If they attach to gamma position carbon atom, then they are said to be gamma hydrogen. So listen, if such alpha type of hydrogen atoms are more in number, then hyperconjugation is more. Are you getting? If what is that? Alpha carbon atoms are more, then hyperconjugation is also more. So listen, in the before class, I told you what is that? Carbocation stability. You know, for carbocation, I take here. Carbocation, especially positive ion, the order is tertiary greater than, secondary greater than, primary greater than alkyl. Correct? So listen, take here CH4. It is an alkyl group. Or you take CH3 plus. Plus is for carbon atom group. CH3 plus alkyl. This is alkyl. So this is itself a carbon, alpha carbon atom. 3 hydrogen atoms are there. Correct? And of course, if any functional groups are attached, then this is alpha. Are you getting? So here, availability of hydrogen atom is only 3. So it may be like this. Here it is plus charge. Then what happens? After resonance, it may form H, here H plus. Or if the breaking of this bond takes place, the resonance structure may be H plus H H. If the breaking of this bond takes place, then the resonance structure may be H H H plus. Are you getting? So this is for what? Alkyl. If it is primary alkyl, so primary alkyl means like CH3, CH2. Understand? So students, this one is alpha, this one is beta position. If any group is attached here, then this become alpha, this become gamma. So of course, this is also showing same type of effect. Means I'll show here CH3, CH, H plus. So in the resonance structure, it may be CH3. Okay, here listen. 1, 2, 3, 4, 5 atoms are there. From this side, this is alpha. From this side, this is alpha. Right? Total 5 alpha carbon atoms are there. Initially, I will represent this. This is one structure. Another one is CH3, CH, another structure, and remaining 3 structure that involves this bond. These hydrogen atoms means C, H plus, H, H, C, H, H plus. Like this. Or this may get the plus charge then. Understand? So initially 2 resonance structure are by these 2 carbon atoms and remaining is from this carbon atom. Okay? Next listen. Another one is CH3, CH, CH3. Okay? Consider this carbon atom means these 2 are the alpha carbon atom because this is the way that, okay, hyperconjugation involves this also. ಅಂದ್ರೆ ಇಲ್ಲಿ 3 ಕಾರ್ಬನ್ ಇಲ್ಲಿ 3 ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿ 3 ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿ 1 ಹೈಡ್ರೋಜನ್ ಎಷ್ಟಾಯ್ತು 3 plus 3 plus 1 7 hydrogen 7 resonance structures are possible. If you take tertiary, it is like CH3 CH3 CH3. Here 3 3 3 9 hydrogen atoms are there, 9 resonating structures are there. Meaning that's why because of the hyperconjugation effects, this tertiary is more stable than secondary, than primary, than alkyl. Because they have here alkyl carbon atoms have only 3 resonance structure. Here this one has 5, this one has 7, and this one has 9. So more number of resonating structure means that is highly stable. Less number of resonating structure means less stable. Understand? If any species representing or possessing more resonating structure, then it is said to be a highly stable molecule. Listen, here we can write 9 possible resonating structures. Understood? So this is what hyperconjugation, and this hyperconjugation is also a permanent effect. It is also a permanent effect, and it is very predominant effect. Very predominant effect means in the molecule all the 4 effects are there. Which are those? Inductive, mesomeric, inductive, electromeric, resonance, and this hyperconjugation. Okay, so which one is most predominant means hyperconjugation. This effect is very strong. It overcome remaining 3 effects. Okay, if resonance is there, that resonance predominates inductive as well as electromeric. And if electromeric is there, that electromeric predominates that inductive. Understood? So this is all about the different effects which we are going to observe in the reaction mechanism. So I will write one by one. Once again. First one is Inductive effect. What is this inductive effect? Means the effect observed by the movement of electron in covalent bond, especially sigma, covalent bond in different electronegative atoms. Different electronegative atoms. Two types is there. One is plus I effect, another one is minus I effect. So plus I effect means when electron releasing group is there. Minus I effect means when electron withdrawing groups are there. Second, electromeric effect. So here the electromeric effect complete transfer of pi bond electron takes place to the adjacent atom. Okay, here also two types is there. One is plus C, another one is minus C. So students, what is plus C? If the atom is bonded to the one to which electron is transferred. The atom is bonded to the one to which one carbon to which electron is transferred. Understand? For example, in the last class I told, here it is the bond is there, here it is like this. Actually, this is carbon atom 1, carbon atom 2. Here any plus species are there. Then the electron shifting takes place with the two carbon atom. Then it is single bond. This one become plus and this one become minus. So this is the positive species. Means of course it attacks minus species. Means electron is also transferred to the same carbon atom and the atom is also bonded to the same carbon atom. That is what plus E effect. Means the atom is bonded to the same carbon atom where electron transfer takes place. Electron transfer takes place to the same carbon atom. At the same time, the atom is also bonded to the same carbon atom. Next, what is minus E effect means? Negative electromagnetic effect. So the atom is bonded to the one in which the electron transfer doesn't take place. Or the atom is bonded to the other carbon atom to which electron is removed. Means, I think so. Here I will show instead of H plus, assume Cn minus is there. Okay, so electron is transferred to this carbon atom, and here the bond is bonded to this Cn minus is bonded to this carbon atom, and both are different. That is what minus E effect. Understood? So the next one, resonance effect. Resonance effect. So what is this resonance effect? The delocalization of pi bond electrons causes polarity of the polarity in the molecule. The delocalization of pi bond electrons causes polarity in the molecule is called as resonance effect. Here also plus R effect is there, minus R effect is there. What is plus R? If the electrons is moving towards the system, then it is plus R. If the electrons are moving away from the system, then it is minus R. This is also called as mesomeric effect. This is also called as mesomeric effect. It is plus n or minus n. Next, the last one is hyperconjugation. Okay, so here the delocalization of sigma electrons takes place. Delocalization of sigma electrons takes place. That effect is called as hyperconjugation. Here I write, so listen, the predominant order. Okay, hyperconjugation is greater than resonance, greater than electromagnetic, greater than inductive. Understand? So this is all about the effects which we are going to observe by the electron transport in the reaction mechanism. Okay. So in the tomorrow's class we will discuss with the next one. Thank you.